Welcome to Defy Robotics. My name's Shactify.
And I'm Bendify.
And this is our project, Fireflies, Arduinos, and Network Synchronization in the presence of distractors. We hypothesized that by modeling Fireflies as independent, interacting Arduinos, that we could develop a simple algorithm that may inform how real Fireflies and other synchronous systems function. Biomimicry is the implementation of natural processes and concepts in artificial structures. Last year we did a biomimicry project, and this year we did a biomimicry project as well. This year we really did two projects, starting with an engineering project where we built up both a hardware and software model of Firefly synchronization. We then did a science fair project where we developed algorithms to extend on Firefly synchronization and studied them.
So, certain species of fireflies will synchronize in the presence of others. The two primary species that do this are Photinus carolinus, which are common to the Smoky Mountains, and Pteropteryx malachi, which are common to southeastern Asia. So, the leading hypothesis on why they synchronize is to attract mates of the same species, such that they can mate as many times during a short lifespan as they can. However, it's not really known how they synchronize, which is what we want to accomplish with our model. So, fireflies have certain restraints on them that we tried to include in our model also, including short eyesight, meaning that they can only see nearby fireflies. They have small brains, meaning that they can only do simple calculations. And we hypothesized that they have to have some way of dealing with distractors, or else they won't be able to synchronize in the presence of others of different species.
Now, our model consists of 24 artificial fireflies. Each firefly module consists of an Arduino powered over USB and connected to a common ground. Each is connected to its immediate neighbors over 3 serial buses and has a red LED encased in a ping pong ball to give a visualization of the algorithm. Now, we developed several different algorithms. First, our simplest is our follow the leader algorithm. Here, one firefly will trigger at random, sending out a propagating signal, which then results in one synchronized pulse. This, however, it properly explains certain species of fireflies. However, other species of fireflies, as noted in a paper, synchronize too tightly to be properly explained by this type of synchronization. So we developed what we call our standard algorithm, where each firefly is looking at its immediate neighbors. It then averages those values and shifts its own blinking towards that average. This allows the fireflies to achieve an even tighter synchronization than the follow the leader. Next, we have our distraction filter algorithm, where the firefly, just like in the standard algorithm, looks at its immediate neighbors, but it disregards the input that's the furthest away from the mean. This allows the system to synchronize even in the presence of a distractor, as Ben mentioned before. Finally, we have our biological cap, where we imposed just a simple cap on the jump length that the firefly can move, or how quickly it can synchronize. This was motivated by biological restraints, and gives our model more biological context.
So, for our first test, we decided to test the effects of jump length on the time to synchronization for the standard algorithm. We found that, as you would probably expect, the large jump length had the fastest time to synchronization, followed by the medium jump length, and finally the small jump length. This result was really expected. However, we had two really unexpected results from our other tests. The first of which was how the distraction filter affects the time synchronization when there is no distractor. And we found that, surprisingly, it actually synchronized faster even when there was no distractor present. This was really surprising, as that was not what the code was designed for. And for the other finding that we found that the biological cap had no significant difference on the time to synchronization of the swarm. This was really unexpected, because we expected that it had a much larger effect because it would not be able to fully go towards the other fireflies in the swarm.
In conclusion, our hypothesis was supported. We developed several different algorithms that synchronize, even given our biological constraints. Further, we developed an algorithm that synchronizes even in the presence of distractors. Now, the clear next step for our system is to take these wires, which are a stand-in for vision, and extend it to real sensors, say a photoresistor. On the biology side, we want to compare our data more rigorously to that of real fireflies to see how our algorithms stack up. Thank you, and see you next time
on Defy Robotics!